Welcome to our deep dive into the fascinating world of light. Over the next 10 minutes, we'll answer some of the most intriguing questions about this essential element of our universe. Light is more than just what our eyes perceive. It's a fundamental force that shapes our understanding of the cosmos. From the smallest atoms to the largest galaxies, light carries information about the universe's origins, evolution, and the very nature of reality itself. So buckle up as we embark on this illuminating journey exploring the science, mysteries, and sheer awe-inspiring power of light. What exactly is light? We encounter it every day. It allows us to see the world around us, but have you ever stopped to consider what it actually is? Light is electromagnetic radiation, energy traveling in waves. These waves form the electromagnetic spectrum. At one end we have long radio waves, at the other tiny gamma rays. In between lies the visible spectrum, the colors we see. Light acts as both a wave and a particle, called a photon. This duality is key to understanding light's interaction with the universe. Light is a cosmic messenger, carrying energy and information across space and time. So, we know light is energy, but how is it actually formed? Where does it come from? Well, light is born from the interaction of matter and energy. One way light is generated is through incandescence. Think of a traditional light bulb. Heat makes the filament glow, producing light. This happens because heat excites the atoms within the filament, causing them to release energy as light. Another way light is produced is through luminescence. In this case, energy is absorbed by an atom and then re-emitted as light. Think of fireflies. They produce light through a chemical reaction, a form of chemiluminescence. Stars, like our sun, generate light through nuclear fusion. Deep within their cores, immense pressure and heat fuse hydrogen atoms into helium, releasing enormous amounts of energy in the process, energy that we see as light and feel as heat. From the smallest firefly to the largest stars, the universe is filled with these cosmic light bulbs, each with its own unique story to tell. Now let's talk about how light travels. Light is always on the move, zipping through space at the fastest speed possible, the speed of light. But here's the thing, light doesn't just travel in straight lines. Remember that wave-particle duality? Well, it plays a crucial role in how light moves. Light propagates as a wave, spreading out from its source like ripples on a pond. And just like ripples can bend around obstacles, light can be diffracted, bending around corners or through narrow openings. But light also interacts with matter as a particle. When light encounters a medium like air, water, or glass, it can be absorbed, scattered, or transmitted. This interaction is what allows us to see different colors and experience the world around us. So light's journey through the universe is a constant interplay between its wave-like and particle-like nature, a cosmic dance that shapes how we perceive and understand the cosmos. Chapter 4. Light Bending, the Refraction Revelation. Have you ever noticed how a straw in a glass of water appears to bend at the surface? That, my friends, is the magic of refraction. Refraction occurs when light passes from one medium to another, like from air to water. As light transitions between these mediums, its speed changes, causing it to bend or change direction. The amount of bending depends on the angle at which light hits the surface and the difference in density between the two mediums. Denser mediums like water or glass cause light to slow down and bend more. This bending of light is what allows us to see through lenses, like those found in eyeglasses, cameras, and telescopes. Lenses use refraction to focus light, allowing us to see objects more clearly or magnify distant objects. So next time you see a straw seemingly broken in a glass of water, remember the incredible phenomenon of refraction at play. Chapter 5. Light Speed Limit, the Cosmic Speedometer. How fast is light? It travels at approximately 299,792 kilometers per second. That's incredibly fast. Light could circle the Earth over 7 times in just 1 second. This speed limit is a fundamental constant in physics. Nothing in the universe can travel faster than light. This concept is a cornerstone of Einstein's theory of special relativity. The speed of light governs the nature of space, time, and the cosmos. Chapter 6. Catching a light beam. Measuring the Cosmic Speedster. Measuring the speed of something as fast as light is no easy feat. Over the centuries, scientists have devised ingenious methods to measure this cosmic speedster. One of the earliest attempts involved using Jupiter's moons. Astronomer Ole Romer noticed that the eclipses of Jupiter's moon Io appeared to occur at slightly different times depending on Earth's position in its orbit. Romer correctly deduced that this discrepancy was due to the time it took for light to travel the varying distances between Earth and Jupiter. This observation provided the first quantitative measurement of the speed of light. Later, scientists like Hippolyte Fizeau and Léon Foucault developed terrestrial methods using rotating toothed wheels and mirrors to precisely measure the speed of light over shorter distances. Today we use highly sophisticated instruments like atomic clocks and interferometers to measure the speed of light with astonishing accuracy. These measurements have confirmed that the speed of light is indeed constant, solidifying its place as a fundamental constant in physics. When we talk about the vast distances between stars and galaxies, using miles or kilometers just doesn't cut it. That's where the light year comes in. Now, a light year might sound like a unit of time, but it's actually a unit of distance. The distance that light travels in 1 year. And remember how fast light travels? 1 light year is equivalent to a mind-boggling 5.88 trillion miles. That's a 5 followed by 12 zeros. We use light years to express the immense distances between celestial objects. For example, the nearest star to our Sun, Proxima Centauri, is about 4.24 light-years away. That means the light we see from Proxima Centauri today left the star over 4 years ago. So when we gaze up at the night sky, we're not just seeing stars as they are now, we're seeing them as they were in the past, their light carrying stories from distant corners of the universe. Chapter 8. You might be wondering, does light even exist in space? It's a vacuum out there, right? Well, yes, space is a near-perfect vacuum, but light doesn't need a medium to travel. Remember, light is electromagnetic radiation, and it can travel through the vacuum of space with ease. In fact, space is the ultimate highway for light, allowing it to travel unimpeded for billions of years. Light from distant stars and galaxies traverses the vast cosmic voids, carrying information about these celestial objects across space and time. Without light, we wouldn't be able to observe the universe beyond our own planet. Telescopes, both on Earth and in space, capture this ancient light, allowing us to unravel the mysteries of the cosmos. So yes, light exists in space, and it's thanks to this cosmic messenger that we can explore the universe and piece together its grand narrative. Chapter 9. We've all looked in a mirror and seen our reflection, but have you ever stopped to think about how that happens? It's all thanks to the phenomenon of light reflection. Light reflection occurs when light bounces off a surface. When light encounters a boundary between two different mediums, like air and a mirror, some of the light is reflected back into the original medium. The angle at which light hits the surface, known as the angle of incidence, is equal to the angle at which it reflects off the surface, known as the angle of reflection. This is known as the law of reflection. Light reflection is what allows us to see objects that don't emit their own light. When light from a source, like the sun or a lamp, strikes an object, some of that light is reflected off the object and into our eyes, allowing us to see it. So next time you check your reflection, remember the fascinating physics of light reflection at play. Chapter 10. Not all reflections are created equal. There are actually different types of light reflection, each with its own unique characteristics. Specular reflection occurs when light bounces off a smooth surface like a mirror or a still body of water. In specular reflection, the reflected light rays are all parallel, resulting in a clear, sharp reflection. Diffuse reflection, on the other hand, occurs when light bounces off a rough or uneven surface like a piece of paper or a wall. In diffuse reflection, the reflected light rays scatter in different directions, resulting in a more scattered, less defined reflection. The type of reflection we see depends on the smoothness of the surface at a microscopic level. Even surfaces that appear smooth to the naked eye, like a piece of paper, have microscopic irregularities that cause diffuse reflection. So the next time you see your reflection in a mirror or on a lake's surface, take a moment to appreciate the different types of light reflection that make it all possible. Outro, thank you for joining us on this enlightening journey through the world of light. We hope you found these answers illuminating, and that they sparked your curiosity to learn even more about the wonders of light. From its nature as electromagnetic radiation to its incredible speed and its ability to bend and reflect, light is a fundamental force that shapes our universe and our understanding of it. So, keep exploring, keep questioning, and never lose your sense of wonder about the cosmos and the cosmic messenger that illuminates it all. Light.